Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the moisture content determination. See, in the previous we already discussed about the determination of the moisture content and the definition of this moisture content. This all things are already discussed. You can go and see the video related to this topic. Uh, we are also discussed two types of moisture content determination. One is your forced draft oven method, forced draft oven method, and the second one is your vacuum drying. Sorry, vacuum oven method. These two methods are already discussed. You will go and see the video related to this topic. Today we are going to discuss the moisture determination content with the help of rapid moisture analyzer, rapid moisture analyzer, microwave drying oven, microwave drying oven, and the last one is solvent distillation. These three methods of the moisture determination will be discussed today, and after that, after the next class, we will discuss about the Carl Fisher, and the second one is your near infrared analyzer. Near infrared analyzer. This will be discussed in the next class. Okay, so first of all, we are going to see what is this microwave drying oven methods are. So what is the moisture content? This will already discuss, and the video related to this topic are already uploaded in our account. You can go and watch the video related to this topic. Now come to the next slide. Microwave oven. See, the main objective of this micro drying oven method are we have to determine the moisture content in a corn syrup and milk, okay, by using this microwave drying oven. So simply we have a two sample. One is your corn and another one is your milk, and milk are in the liquid form. So what we have to do, we have to determine their moisture content, and for this purpose we are using the method that is your microwave drying oven. Okay, this is the object of our experiment. Now the next one is your principle of this method. So what should we do? We have to heat the sample. Here the sample are what? Here the samples are either we take a corn syrup or we take a milk which is in liquid state. So what should we do? We have to heat this corn syrup and milk in a microwave oven, and how they are heated, they are heated with the help of microwave energy, and when they are heated there is a loss of weight, and with the help of this weight we are going to calculate the moisture content of the sample. This is the principle behind this experiment. Now see what is written in the slide. The sample is heated using a microwave energy, and the loss of weight is used to calculate the moisture content of the sample. So when the weight is lost, then with the help of this weight, what should we do? We calculate the moisture content of the sample. Now come to the next slide. Material. See, the material which is used for this experiment, the first one is your corn syrup. Okay, corn syrup is what? It is a sample. So the first material is what? It is a corn syrup, and the amount of the corn syrup is around 4 gram. The next one is your glass stirring rod. Okay, this glass stirring rod is used to spread the corn syrup into a plate. And the second sample is your milk, and the weight of the milk is again it is 4 gram. Again we require 6 paper pads. Okay, this 6 paper pads are used in a microwave oven. we also required a pasteurized pipette and bulb, and this pasteurized pipette and bulb are used to spread the milk. Pasteurized pipette means that it is free from any type of pathogenic microorganism. Pathogenic microorganisms. Okay, which means that it is not capable to cause disease, and we are also required a plastic gloves. This pasteurized pipette and bulb are required to spread the milk sample, and the glass stirring rod are required to spread the corn syrup. Now the next one is your instrument. Here we only use one instrument, that is your microwave drying oven. Okay, for example, CEM Corporation, Mathif, NC. Any type of microwave oven we can use for this purpose. Now come to the next one, procedure. Here the procedure are very easy. We have to simply follow the instruction which are already given in the microwave drying oven, and this instruction are given by the manufacturer. Okay, so simply what should we have to do? We have to read this instruction. What we have to do? We have to read this instruction, and we have to follow this instruction. Okay, by this way we can easily handle the microwave oven. So first of all, we have to turn on the instrument and warm up. After warming, what should we do? We set the time, power, etc. Okay, then after that we tear the sample, and again we put a testing sample into a microwave oven, and by this way we obtain the result. This is very simple way. What should we do? Simply we have to turn on the instrument and just wait it for that warming. After warming, we just set a time. The time, so suppose that we require that 30 times or 50 volt or 100 volts. So it depend upon the instruction which are given on the manufacturer. Okay, then after that we tear the instrument, means that if any reading are present, then for this we just put a sample instrument reading to a 0. That means that we tear it. Then after that we put a testing sample into it and wait for a result. When result is appear, then we obtain that result. Now come to the next one, data calculation. See, data calculation are very simple. Suppose that we repeat it. Okay, so we repeat a corn syrup for a 3 time, 1 2 3, and here we put, suppose that in a first time we have a 31.1%, anything like this. So after that we take a mean and write down. Okay, simply here for a milk, three values are arises like X, Y, Z, then we take a mean of it, and this is the moisture content of the milk liquid. Now come to the next one. The next method for the analyzing of the moisture is rapid moisture analyzer. Okay, simply what is the objective behind this rapid moisture analyzer is that we have to use a corn flour for the determine. We use sample corn flour for the determination of the moisture content by using a rapid moisture analyzer. This is your instrument. Rapid moisture analyzer is what it is, an instrument, and this corn flour are what they are, a sample. So simply what should we do? We use this rapid moisture analyzer to determine the moisture content present in a corn flour, which is our sample. Okay, now come to the next one, principle. The principle behind this experiment is that, first of all, what should we do? The sample placed on a digital balance is heated under a controlled high heat condition, and the instrument automatically measure the loss of weight to calculate the percentage or solid. This rapid moisture analyzer are what they are, automatic. Here our digital balance are present which are heated under a controlled heat condition. Okay, when we put a sample into a digital balance, they automatically measure the loss of the weight, and according to their loss of the weight, they calculate the percentage of the moisture or the solid. So this is how we simply calculate the percentage of the this sorry, percentage of this sample, or here the sample, or what we have a corn flour as a sample. So basically this is the principle behind this experiment. So the next one is your material. Here we required only three material. One is your corn flour, okay, and the weight of the corn flour is around 10 grams, and we required a plastic gloves and a spatula. Plastic gloves is to hold the plate, and spatula is to introduce this corn flour into a plate. Now the next one, instrument. Again we required only an instrument, that is your rapid moisture analyzer, because it is totally uh, automatic. For example, computerized are Arizona Instrument LLC and Chandler AZ. So these are the instrument or type of instrument which are used as a rapid moisture analyzer. Okay, so basically these are the instruments which we use for this purpose. Now the next one is your procedure. Again the procedure are the procedure, in procedure what should we have to do? We have to simply follow the instruction which are given by the manufacturer for the use of this rapid moisture analyzer. First of all, again we have to turn on the instrument and leave it for a warming. When it warm it, then we have to select the test material. Okay, then tear the instrument, then put a testing sample and obtain the result. It is very simply, what should we do? First of all, we have to turn on the instrument and leave it for a warming condition. When it is warm, we select a material. Okay, suppose this we have to take corn flour, or we have to like that. Then after that we tear the instrument, again we tear the value to the zero, then we put a test sample into it and leave it for a result. Now the next one is your data calculation. Here simply what should we do? We again we determine this moisture content of corn flour for a three time, 1 2 3. Suppose we get A, B and C, then here what should we do? We calculate the mean of this. Okay, so this is how we calculate the mean. Means that we have to take a average of moisture content of the corn flour with the help of rapid moisture analyzer. Now the next one is your Tolvin distillation. Okay, now what should we do? We determine the moisture content in a vessel with the help of Tolvin distillation method. Okay, we already discussed about the microwave drying oven method. We already discussed about the your we already discussed about the rapid moisture analyzer, and now we are going to discuss about the Tolvin distillation method for the determination of the moisture content. Now here the sample are what? Here the sample are a vessel. Okay, now principle behind this, the moisture in the sample is co-distilled with the toluene, which is immiscible in water. The mixture that distill off is collected and the volume of the water removed is measured. Okay, now what we have to do? We take a sample like basil, and this basil is co-distilled with the toluene, and these basils are immiscible with the water, and the mixture of that distill is collected, and then after that the volume of the water is removed, and we have only what? We have only a vessel. Now the next one is your chemical which is required for this experiment. We required only one chemical, that is your toluene. Okay, the case number is 108-88-3, and the hazard related to this toluene or chemical are what? They are harmful, highly flammable. Okay, so for this purpose we have to take a care for handling this chemical. Now the next one your hazard, caution and waste disposable. We all know that this toluene is what? They are highly flammable, so if we inhale it, then it will create a problem. Okay, so that's why we have to use a ventilation area for this method. Okay, we have also wear a glasses and gloves, and all the disposable of the toluene waste, sorry, all the waste which are generated by the toluene is to be disposed separately, and along with that we have to follow all types of good laboratory practices which come under the category of environmental health and safety protocol, and we have also follow the safety protocol which are given by our institute. Okay, now see what is written in the slide. Toluene is highly flammable and is harmful if inhaled. Use advocate ventilation, wear safety glasses, gloves at all time. For disposal of toluene waste, follow good laboratory practices outlined by environmental health. So when we are disposed this toluene waste, so we have take one care that environment should not be affected by this toluene, and we have also follow the safety protocol which are given by our institute. Now the next one is your material. Here the material which is required are fresh basil 40 to 50 gram, NFDM 4 to 50 gram, toluene, and the grade of this toluene is ACS grade. Now the instrument required, we required a analytical balance. The first instrument which we required are a analytical balance, and this analytical balance can measure around it at 0.1 milligram also. And we also required a glass distillation apparatus with ground glass joint. The first one is we required a 250 ml or 350 ml of boiling flask, round bottom flask, short neck flask with TS24 oblique 40 joint. We also required a vest condenser with a drip tip whose length is around 400 and with a TS24 by 40 joint. We also required a Bidwell Stirling trap TS24 40 joint 3M capacity graduated in 0.4 ml interval. We required a heat source capable of reflexing toluene in a apparatus above, and we also required a nylon Bristol burette brush of half in diameter and wire loop, and it should not be long enough to extend through a condenser 450 Flatten the loop on the burette brush and use this brush inverted as a wire to dislodge moisture drop in the moisture trap. So this is the instrument required for the determination of the moisture with the help of solvent distillation. Now the next one is your procedure. So first of all, what we have to do, we have to grind this fresh basil. Okay, and for this purpose, what we have to do, we have to use a food grinder. Okay, now what we have to do, we use a food grinder for the crushing of this fresh basils. Now pulse grind the sample in 5 to 10 interval. Avoid long pulses and excessive grinding to prevent the frictional heat. Now after that we have to take a weight of the sample, and the weight of the sample is around 40 gram. Okay, and this weight should be accurately. Now after that we have to transfer this sample into a distill flask, and we have to add a toluene into it, and the amount of the toluene should not less than 75 ml. And when we added the toluene, we have to cover the sample. After that we have to assemble all the apparatus properly and fill the trap with toluene by pouring it through the condenser until it just fill the trap and begin to flow into the flask. When the toluene are flow into the flask, then we have to stop to putting that toluene into it. Then we have to insert a non-absorbing cotton plug from the top of the condenser so that the condensation of the atmospheric moisture in the condenser should be prevented. Now we have to boil the material and to the boiling point and reflex at about 2 drop per second until most of the water has been collected in the trap, and this will increase the reflex rate to 4 drop per second. Now this process will be continue until we have get two successive reading, and the successive reading should be 15 minutes apart, which show there is no changes. Now continue reflect, sorry, dislodge any water held up in the condenser with a brush or wire loop. Now we have to rinse the condenser with the help of 50 ml of toluene. Dislodge any moisture droplet adhering to the bidwill, trailing or toluene trap under the collected moisture. For this, use the wire, rinse the wire with a small amount of 10 ml of toluene before removing from the apparator. Now we have to continue this reflexing for 3 to 5 minutes. After that, we have to remove the heat and leave it for a cooling for a at leave it for a cooling so that the temperature will be reaches 20 degrees Celsius. Now we have to calculate the moisture content with the help of this formula. Moisture content is equal to volume of water that we have to take in divided by weight of the sample multiplied by 100. So this is the formula for the moisture content determination. Now here weight of the sample and volume of the sample and the moisture content. Suppose that you have to take a two consecutive reading, then you can also put it into this table. So this is all about the determination of the moisture content with the help of microwave oven, rapid moisture analyzer and solvent distillation. Thank you for watching. Please like, share and subscribe our channel. If you have any query, just let us know in a comment box. You can also send your query to the helpline number that are already mentioned in your slide. You can also follow the ITLS Academy on different platforms like Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe the ITLS Academy on YouTube and get our app from a Google Play. Thank you. If you have any query, just let us know in a comment box.